In this segment, we're going to be covering roots and radicals. We've already worked with exponents, and we of course know that if we take 3 and square the 3, we get a 9. Now, what we would like to do is to do sort of a reverse process of that and to say, what is the number whose square is 9? That's called a radical. And you probably have seen or are familiar with the radical sign. And so if I take the radical of 9, in this case the square root of 9, and of course the number for which this works is the number 3, because when I square 3, so this is called the square root of 9. Of doing exponents. For example, let's take another one. What about the square root of 16? We're looking for a number whose square is going to be 16. Here, I want that number squared to be equal to 16. Well, we know that that's going to be 4, because 4 squared equals 16. So now I can say the square root of 16 is equal to 4, because 4 squared is 16, right? But we have another possibility here. So I have two possibilities then for the square root of 16. The square root of 16 could be equal to 4, or the square root of 16 could be equal to a negative 4. Let's consider another radical, and this time we're going to be thinking of a radical. We're going to put a little number there, which is a 3 of 8. What I want in this case is I want a number whose cube, if I cube that box, I end up with 8. Well, as you well know, if we take 2, so we can say that the cubic root of 8 is equal to 2, because when I cube the 2, I end up with 8. But now let's look at another number. What about the cubic root of negative 8? Okay. So what I'm looking for, I'm going to get rid of the boxes right here. I'm going to say I'm looking for a number a, so that when I cube the number a, I end up with a negative 8. The nice thing about cubes is that if I start with a negative number and I cube it, I do end up with a negative number. And so it turns out in this case that the number 2 will negative. Okay. Now, notice what we did with the square roots and with the cubic roots. We said if I take the square root of 16, I can get a, or I can get a negative 4, right? But with cubic roots, that's not the case. We have only one possibility. If I take the cubic root of 8, I end up with a positive root of negative 8. I end up with a negative 2. For square roots, there are two possible answers. For cubic roots, there's only one answer. Cubic root of a positive is positive. The cubic root of a negative is negative. Okay? In the same way, if we look at the root of a number b, for example, what I'm looking for is a number a, so okay. For example, suppose that we have the square root of a negative 4. In this case, let's say I'm looking for a number a, so that when I negative 4. But that's impossible if we're looking at real numbers, because here a squared is a positive number, where negative 4 is a negative number, and a positive cannot be equal to a negative. Okay? So the problem comes up when we have even roots or the square root of a negative number. That turns out to be not a real number. In the course, you're going to find that the real numbers are going to be extended so that we will actually be able to take the square roots of negative numbers and end up with numbers which are no longer real, but they are what is called complex numbers. Okay? So let's try to do a little summary then of the things that we have talked about with square roots and cubic roots. Square root of a positive number. We will take the positive answer and call this is going to be the principal square root. Okay? And when we want the negative square root, we will indicate that. We've also seen that we cannot take the square root of a negative number and end up with a real number. Is not a real number. As we've seen with cubic roots, that is not a problem. If we take the cubic root of a positive number, we end up with a positive number. If we take the cubic root of a negative number, again, we have only one choice, and we end up with a negative. Each of these is called the principal cubic root. Okay, the same thing for this one. This is also a principal cubic root.